Here we will practice one example on analysis of bivariate data. As an example data set, we will use this table. Here this table shows the dependency of life expectancy on GDP per capita for 181 countries in the world. So to analyze this bivariate data, we will use this calculator. First, we will take an empty data sheet and we will set this first column as GDP and the second column as life expectancy. Now in this first column we will enter all this GDP data starting from $1,200 to $29,000. So 1200, then 2800, in this way up until $29,000. The last one is 29,000. So now once we entered the GDP data, we will go on the top and we will start entering the life expectancy data starting from 52 to 79. The last one is 79. So once we entered all our data, we will go on the top and now we will analyze it. So the first analysis that we will do, we will want to find the correlation coefficient. So we will click the menu, statistics, stat calculation. Now it's a bivariate data, so we will select two variable statistics. Now the X list will be selecting the independent variable, that is the explanatory variable, which is GDP. Here in our example it is GDP, and the Y list will select the dependent variable, that is the response variable, which is life expectancy in this example. Then we will click OK. So now here we are getting the two variable statistics. If we scroll down, we will get this R, that is the correlation coefficient, which is 0.8767. So it is a high correlation, that is a strong positive correlation. In this analysis we can also see the individual variable, that is GDP and life expectancies analysis also. So for example, the X we used GDP and Y we use life expectancy. So X mean, that is GDP mean, is $14,257. Its standard deviation is $8,852, and Y variables mean, that is life expectancy's mean, is 71.7 years and its standard deviation is 7.3 years. We can also see the 5 value summary of the data. So for example, mean X, that is GDP's minimum value is 1200, maximum value is 29,000, and its first quartile is 6800, median is 14,000, and third quartile, that is upper quartile, is 21,000. Similar way we can see the summary of Y variable, that is life expectancy. Minimum life expectancy is 52 years, maximum is 80, first quartile is 68 years, median is 73.5 years, and upper quartile is 77 years. Now we did the analysis and we got the correlation coefficient. Now we will be drawing scatter plot for this bivariate data. To do so, we will click in this home icon. We will take a new plot area. Now this data is showing in a scattered way, but we need to select the variable. In the x-axis we will select the independent, that is the explanatory variable. We will click here. GDP is our independent variable, and in the y-axis we click here. Life expectancy is our dependent variable or response variable. So this is the scatter plot. So we got our scatter plot. Now we will draw a line of best fit. To do so, we will click menu, we will select analyze, we will select regression, and we will choose linear regression, and the equation is y equals mx plus b, this form. So this is the line of best fit, that is the regression line. and this equation y equals 0.000724 times x plus 61.39. So this is the regression equation, and we can see from here the line is steep enough, so it is a strong positive correlation exists between GDP and life expectancy. That means we can conclude that the life expectancy of people depend on the GDP per capita of corresponding countries. Thank you.